Okay, for today, it's about taking quadratics or absolute values and solving them both with algebra and graphically. So here's a typical question. Say we have the absolute value of x minus 4 needs to be bigger than 5. Well, we have to be able to solve it with algebra or with graphing. So let's start with algebra. To solve this thing, act like it says equal to 5 and solve it. Go ahead and just solve it like normal for absolute value of 4 minus x equals 5. Did you say x minus 4 equals 5 and x minus 4 equals negative 5? Good. And then you solve those two, you get x equals 9 and x equals, let me think, add 4 to both sides, negative 1. We'll talk later. I'm not recording right now. Let's see. All right, so I have two answers, 9 and negative 1. All right, but what did we change? What was the original problem, actually? Greater than. Okay, so what we do is go through and go like this. It's supposed to be greater than 5. So instead of an equal sign, I'm going to use greater than 5 and greater than 5. But on this other side, I changed it to a negative 5. That's like multiplying by a negative. That switches the sign to less than and less than. Does that make sense to you? Because this one's the opposite of what this one is, we have to switch the sign. And whenever we did that on equations before, inequalities, when you multiplied by a negative and made everything opposite, then the sign had to switch too. Okay, so now I'd like you to just put this on a number line quick and see where they overlap or where they are. Things that are greater than 9 and things that are less than negative 1. Maybe they'll overlap, maybe they won't. Less than negative 1. Bigger than 9. Okay, they don't overlap. There we go. There's my answers, though. Now, what's another way you could write this? What type of notation starts with an I? Interval. Everybody write this with interval notation. From where to where, and then from where to where. What'd you get, Miss T? Yep. Okay. That's solving it algebraically. But I think it's really worth stepping back to the beginning here and saying, what would this have been in a picture, graphically? Let's say that this is graphed in blue. Do you get it's a V shape moved right 4? Does that make sense to you so far? Okay. Where is that bigger than 5? Well, if I graphed this as a y equals something, then I could also graph this as a y equals something. So it's hard for me to keep the scale right here, but I'm pretty sure I'm about right there for 5. Y equals 5. And now the question is, where is the absolute value bigger than? Do you get what I say? Bigger than? Greater than is bigger than, right? But bigger than also implies higher than. Where is the V shape higher than the 5? Do you get that I'm talking about this little area right here and that little area right there? That's where the V shape is bigger than or above or greater than, they all kind of mean the same thing, the 5. So then my interval is from forever till here, and then from here over. Remember, it's always x For intervals, it's always x numbers. Okay, so then I just got to know these points, where they crossed. Well, I happen to know them because we solved this already. They are -1 and +9. This is -1 and this is 9. You get in a picture, it's where the one function's above the other. All right, so everybody, with this next one, I'm gonna have you do it by hand first, and then I'm gonna have you check yourself with your calculator. In case you forgot where absolute value is, find it under the catalog button, which is above the 0 on your calculator. So go to catalog. Okay. So this problem was a good example. I'm going to give you another just like it for absolute values. Absolute value of x minus 11. Now let's make the numbers small because that'll go off your graphing calculator window. You have to mess with that. Is going to be greater than, just make it 3. Here we go. Solve that by hand and write your answer in intervals. Then solve it with the calculator by graphing y equals the left and y equals the right. I'm going to pause while you give that a try. Okay, I'm going to show people how to type this into the calculator. Absolute value I'm finding as second 0. That brings up the catalog, which, in case you've never noticed this before, it's got the little alpha thing up here, which means it's alphabetically sorting it for you, which brings absolute value right to the top. But if you wanted something like GCF, you could just type in the letter G, which is this green G above the tangent, and it would bring you right to G, like for GCD, just so you can like know how to find things really quick. It's sorted alphabetically. Now I want to go back to A for absolute value, so I just hit the A key, which is above math. It's sorting by letter then, by alpha. All right, so I'm going to use absolute value, x minus 2, and then just y equals 3. Now I hit graph. And that's how you'd put it in the graphing calculator. But you're also supposed to solve this by hand. So solve it by hand, and you'll know what the intercepts are by hand. I'm going to pause for a little while longer, and then I'm going to show you how you use the calculator to tell where they intersect. Okay, so here's how you find where two things intersect. I'm going to go to second, calculate. It's right above trace. And then I go down to intersect, which you can either arrow down to or you can hit the 5. But that doesn't just do it, because there's two places where they intersect. Then you got to move the little spider thing close to where they intersect. Now I'm choosing the one on the left. Later I can do the one on the right. So once you get really close there, it's asking you first curve, which means am I on the first of the two lines you're going to have me intersect? I really wish they just would jump right to one of the intersection points and make people do this with only 2 lines. But TI wanted to be able to have people graph like 5 different lines and then be able to see where these two intersect, and now where these two intersect, and now where those two intersect. So that's why they do it this way. But here's the shortcut around it. Just get really close to where they intersect and hit enter, enter, enter. It's really, really fast. Okay? Now, of these groups, there's somebody who's to the right of the other. Okay? The person that's on the right, I want you to go to the other intersect and show them the key sequence, type it in front of them, and show them how to find the other two intersecting points. And if somebody doesn't know, then help them. I'll pause while you try this. Okay, I think we've all got second, calculate, intersect down. I'm going to show one more time. So if I was going to get the other intersection point, I go second, calculate, and intersect is the 5th one, so I hit 5. Then you got to get the little spider thing by where they cross. And I could technically hit the enter anytime because I'm on the first curve. But the smartest thing for me is just get them really close and go enter, enter, enter. And there we go, 5, 3. Now why are those so important? Because it told me that the intersection points were -1 and +5. And those two spots where they cross are really important. So here's my V. Here's my line. And this is at -1. And that's at 5. Notice it's the x value that's important here. Okay, so then if my answer was here, then I'd say the answer was between -1 and 5. If my answer is, in fact, here, then I'd say the answer is from -infinity to -1, because they're like this. And then from 5 to infinity. All right, so which is it? Well, I want the V shape to be bigger than the 3. So it is this one. So it is from -infinity until -1, union with 5 to infinity. Raise your hand if you had that one right. Okay, good. Do you feel like you can do that algebraically and graphically? All right, good. Now, here's how you, now I know some of you just heard that, oh, I can use the calculator for the test. So that means I really didn't need to know that vertex thing. I mean, like, how can you force me not to use the calculator if it's a calculator allowed test to find the vertex? I mean, you could use the calculator for that. True, if we gave you one you could graph. How could we keep it from being, how could we keep you from being able to use the calculator? By throwing in an A. So what's the vertex now? Well, you need that formula. What's the little formula? -b over 2a. What is -b in this case? That's b. So it'd be -2a all over 2a, which is 2 times 1, which is 2. And then the -2 and the 2 can cancel a little bit. The 2 can cancel at least. I got -a over 1, which is -a. Just saying, don't try to think that, oh, since I have a calculator, I don't have to even know how to find the vertex. You do. You'll have to either complete the square or you have to have -b over 2a figured out for that. Okay, so now the next part is about quadratics and how to set them bigger than something. Like, let's say I said x squared plus 3x is less than 7. You can graph x squared plus 3x and then graph 7 and see where is the parabola part less than the 7 part. That'd be here. And so obviously you'd need to find these 2 points, and they would be the key. Okay, so where the 2 things intersect is still important. All right, so it's pretty much the same idea when in graphing. You just graph both sides, and you see where they cross, and you just see where the one is lower than the other. Okay, but if you had to do this by algebra, your first step has to be to set this thing equal to 0. X squared plus 3x minus 7 is less than 0. And then, my favorite saying applies. Can factor it. You should. And then, who knows the other part? If you can't factor, quadratic formula. Good, because this one you cannot factor. So then you'd have to use the quadratic formula to find them. What it's finding you is these spots. I know that's weird, but it's because we rearranged the equation. We subtracted 7 from both sides of the equation, and so it doesn't look right. It seems like, isn't it supposed to be where it touches the x-axis? Yes, except if you rearrange the equation in the first place. All right, so let's just finish this off, except I'm going to do the quadratic formula for x equals -b, -3 plus or minus the square root of b squared, which is 9, minus 4 times 1 times -7, all over 2a, which is 2. And then this part becomes positive. 28 plus 9 is 37. So it's -3 plus and minus root 37 all over 2. And obviously that doesn't work out real nice, but it's a positive decimal and a negative decimal. And that's where we got here. Those are our x values here, here. Okay, Now let's actually have you start some in class here. I know this feels a little bit difficult. That's okay. We have 2 days on it. We have a day to talk about this plus a little bit more on Monday. All right. So if you were to look at this problem, we're not going to actually do this problem together, but if you just look at this problem, where they intersect is like, oh, come on. That's so easy, right? Just put in stars there. Fine. I'll put some stars there. Then where is the one function less than the other function? You got to keep them straight. F of x is this one. So I'm going to use blue and black. So where is the blue one? I probably shouldn't use blue because this is color with blue. Okay, fine. I'm going to use green for it. Where is the green one less than or below the other one? In there and there. And so my answer would be from negative infinity until negative 1, and from 1 to infinity. All right. Hope you're getting as well as I think you are. So here's our first problem. And to cut this down to a little bit smaller assignment, because you guys have the lab to get done over the weekend too, cut that one out. You want to put a white box over it, sticky note. If you use a little plus sign and then stickies, if you add a sticky, then you can write over the top of the sticky. It's kind of cool. It gives you more room to write. So I want you to do 1 and 6. And it does say solve it. It doesn't say with a calculator or not. I'm going to recommend that you do it and then check it with the calculator. I would recommend you do it by hand. You're going to have to be able to do both on the test. Okay, so if I was going to do this by hand, I'd split this into 2 equations. 3x minus 5 is less than or equal to 4, and 3x minus 5 is greater than or equal to negative 4. And I'd solve my 2 little equations, and I'd put the answer on a number line, because number lines, to me, make the most sense. Then you can check it with the calculator and see where is this V shape and this 4, where do they intersect, and then is it below? Yeah, it's once it's below the 4. It'll be like this area. So it's from there to there. But you'll use a calculator for that. So do it with algebra, and then check yourself with the calculator. You have to be able to do both. Okay, these, there's too many of them. I'm going to have you skip this one. And this one. Oh, you know what? It's not, I probably should leave that one because it's different. This is sandwiched between 2 and 7. When you graph this one, you'll have 3 lines. You'll have this line that's been moved over 4, and then it's going to be between the 2 and the 7. So it's like this part of the line and that part of the line is where it's between 2, where the V is between 2 and 7. All right. So you can do 7, 17, and 21. Here we are skipping this whole page. Skip the purple page. And this one, we can skip the top one, but you should try this one. When we throw in a variable, that makes it honors pre-calc level. Otherwise, you had done something similar to this just last year. You already did absolute values. So anyway, throwing in a variable makes you think, okay, well, how far is it going to move? It adds extra little bit of challenge, but it's not super hard. Okay, I already did the Friday quiz, so that's it. So now I'm going to get back and actually start this. I was going to put it all on a number line. Here's where 1/3 would be. Here's where 3 would be. And it's less than 3 or equal to 3, and bigger than or equal to 1/3. There you go. There's your answer that way. And then you do it with a graphing calculator. Check that you get the same thing. That's between negative 1/3 and 3. Okay, that's all I got for you